video, I'm going to go over the mock paper. The first question is about this particular function. So what I'm going to do is I'm going to plug that straight into the calculator. You can see I've already done it here. Instead of t as our variable, we are going to put x, as the calculator can only do x. Instead of w of t, which is the water over time, we are obviously going to just deal with y. The first question is, find the initial amount of water Miss Rowlands placed in the pan. Initial is when time is 0. So if you didn't know that, write that down. So when time is 0, it is 36. And you can see here, it's simply 36 in the function. So if we've got a function which is a, b to the power of c, our initial amount is always going to be whatever a is. Find the percentage of water that evaporates each hour. For this, we need to go to Jamboard. So if we have a look, it goes from 36 to 25.2 to 17.64, and this is the number of litres of water. So how do we work out percentage change? Well, we're going to go from the final amount to the original amount. So final divided by original times by 100 is going to give you an answer to do with percentages. And if you don't know that, this is prior knowledge. So if we go from a final amount such as 25.2 divided by 36, you can see that we've got 70%. Now the actual change is how much does it drop from 100 to 70? Well, clearly the answer is going to be 30. If you look at the question itself, this is really obvious because it's just the 0.7 here. If again you've got a function where you've got a, b to the power of c, the percentage change is always going to be related to whatever b is. So it will either be below 1 if we've got a decreasing function normally, or above 1 if we've got an increasing exponential function. Then it says calculate the amount of water in the pan after 5 hours. Very simple. You just take your t and you're going to substitute 5. You're going to go down to the 5. After 5 hours, we have 6.05 litres left. Checking the mark scheme, we are going to have the following answers. 36, 25.2 is the change. So therefore, we've got a 30% decrease, and then we've got 6.05 litres at the end. Let's go on to question 2. This wants us to find out the median. So to find out the median, we look at the box plot. We check out the line which goes through the middle of the box, which is here. It's going to be between 11.5 and 12. And you can see there are 5 jumps. So each of these jumps represents 0.1. So it's going to be 11.7. I was a little bit lenient in the exam because the grid may have not been so clear. Interquartile range, again, prior knowledge, something you should know. It's the difference between the lower quartile and the upper quartile. We are going to have a jump of 1 and then almost a jump of 2, but it's a little bit less. It's 0.1 less, so it's going to be 1.9, the length of the box. Miss Stephanie interprets this box and claims that the percentage of students taking a less than 10.5 seconds is equal to the percentage of students taking longer than 12.4. So let's have a look. This is going to be the percentage of students between 10.5 and 10, and we know every part of a box plot is split into quarters. So we'll have a quarter of the population here, 1 quarter here, 1 quarter here, and then finally 1 quarter here. So clearly the answer is going to be she is indeed correct. But why? Well, each section is worth the same percent. So in order to get the mark for this, you needed to say correct and the answer. You weren't allowed just to have 1 mark for this question. It was either 0 or 2. Moving on to question 3. It's about Mr. Wicks rehearsing for Sotter Rocks. So let's have a think about the first question. The trumpet has a sound intensity of this. Calculate the loudness of the trumpet. Well, all we need to do is substitute this into our function. And we just need to be able to find log on our calculator. So let's do that. Opening up our calculator, going onto the normal menu. If something is log to the base 10, that is just log on the calculator. We just press this button here. So let's go. 8 log, and then I is 1.08 times 10 to the power of minus, make sure you use the small minus, 4. Close brackets, plus 150. Really easy marks there. The answer is 118 to 3 significant figures, or you could write out the whole calculator display. He then tests the smoke machine. The smoke machine sets off fire alarms. This has a loudness of 162 decibels. Now this time we're substituting for the D, not the I. Now there's multiple ways you could do this, but I would really recommend you do this on the graph. So first of all, we're going to type in the function again, unfortunately. So we have 8 log I. I is going to be x plus 150. Now we know the answer to this question is going to be 162. So in y2, we just put 162, and we're going to see where these graphs intersect. Sometimes it's quite difficult to see where the graphs are, so you have to manipulate with the window. We can see the function has got something to do with 150, which suggests that I need to make the window quite significantly bigger. So I'm going to change each of these variables maximums to roughly 200, and I see that looks like a much better graph. You can still see that I've got far too much on the y-axis and far too much on the x-axis, so I'm going to zoom in. So it's a higher number on the y-axis, and x we don't need very much at all. So for x I'm going to just change it to 30, say, for example. The y, we want to keep it near the bigger numbers, so let's change it to 150 and see what this looks like. There we go. We can see it intersects roughly here, so we're getting there, but we're still not quite there. So let's make x bigger again. Let's make this 50. Let's press graph. We can see the intersect here. So this is where our answer is going to be. To get the intersection, you press second calc, intersect, which is 5. You go from the first curve, which is the blue curve, to the second curve, which is the red curve, and then you go roughly where they cross, which is here. And that's going to give us our answer of 31.6. So there we go. We've got 5 marks already in place for this question. If we have a look at the answers, just to clarify, 118 to 3 significant figures, or you could write your full calculator display and then 31.6. It's put the units in brackets because it's not always required for the full marks, but I would recommend you write it down just in case. Let's go on to question 4. So this question is a little bit more challenging. So the first thing we want to do is find the Pearson's product moment correlation coefficient, which is R. Pearson's itself is not challenging, but perhaps when we get on to doing Spearman's, you have to do a little bit more thinking. So in order to do Pearson's, you are going to get to the calculator and you are going to clear both of the lists. I do this by just going to L1 and L2 and pressing clear and then moving off. Then we're going to put in these numbers. Instead of horizontally, we're going to be going vertically. 25, 20, 20, 19, 17, 22, 19, 10. Let's do list 2, which is the score of Y. We're going to have 42, 40, 30, 32, 30, 36, 28, 27. I would always recommend you check. First of all, I check if they're all 2 digits. They are. Check to see if we've got 8 entries. We do. Then I might check the numbers quickly. 500972. Looks correct. Let's check the second list. 2002067. Indeed, it is correct. How do we find Pearson's? Well, this is on the TI-84 help sheet. So remember, if you're revising, you need to make sure you've memorized the TI-84 help sheet steps. All of these steps will be required for both of your exams. So let's have a look. If we search for Pearson's here, we are looking for R. So these are all the different steps. You can pause the video and look through this in your own time. We are going to go over to calc. We're going to go down to lin regress, which is ax plus B. We're going to put list 1 and list 2 because we're using both of the variables. And then all we do is press calculate. There we go. Our R is simply going to be 0.747 to 3 significant figures. Let's do the part 2. Using this value of R, interpret its relationship. So all you need to say for this question, it's 1 mark only, is that there is a strong relationship and it's positive. It doesn't really matter whether you write very strong or moderately strong, just write strong and positive. And if it was 2 marks, you could say, as revision time increases, so does the IB score. As one variable increases, so does the other. A student in Mr. Mohammed's class has decided to study for 30 hours. Would it be reliable to use the regression line for their IB score? Now, you're going to have a look at all of these revision times and you can notice there's nothing over 30. So there's going to be some sort of answer, probably to do with saying no. You say no. You can use the word extrapolation because it's outside of the data range. Now you can say that in a sentence, but if you memorize this, this is much easier to say. Now we want to rank them. Well, what does rank mean? This means Spearman's rank. We're going to rank them from a way in which where we're ranking the biggest number as number 1 and the smallest number as number 8. So how does that work? Well, let's have a look at the answers. The answers are given here on the right hand side. 1. Why is that 1? Well, 25 is the biggest. 2. 22 is the second biggest. Then we have 20 is the next biggest, but we have 2 numbers which are 20. So the next ranks we would have available are rank 3 and 4. So we go halfway in between 3 and 4 and we write down 3.5, 3.5. We continue that process. Then all we do to finish this question is we put all of these numbers into our calculator. If in the exam you haven't got the correct numbers, you will get the marks if you write numbers down. You will get the marks for the next part of the question. We're going to go on to stat, we're going to go on to edit, and you just put these numbers back in the list. So 1, 3.5, 3.5, 5.5. And you would just complete both list 1, list 2, and you would do the same process we did previously to find what R is. It's really quite simple. You get this as the answer, 0.830. And the final question is, explain why this doesn't change when a value is changed. So we're going to say, actually, student H studied for 15 hours and not 10. So H studied for 15 hours. We can still see that H is going to give us the lowest number, which would give us the highest rank still. So you just said, you would say something like H would still be ranking the lowest, therefore it wouldn't affect the Spearman's rank. Voronoi, our favourite, but you can see this question is quite nice. So we are going to have a look at the coordinates of the largest empty circle. Now, this sounds more complicated than it actually is. So what are we going to do for this? We are going to have a study of the diagram. What does largest empty circle actually mean? Well, we have gone over this multiple times in class. So we are going to get a pen. This is our pen. And when you have a system, a Voronoi diagram like this, where you have 4 unique cells and 2 vertices in the middle, what you end up having is a pattern where 3 of the vertices are equidistant from 3 of the sides are equidistant from one of the vertices, and then the other 3 are equidistant from the other vertice. So we can see that the distance from B to F is also equal to the distance from A to F, which is also equal to the distance A to C. So this is creating a part of a circle in a way, because C to F is the same distance as F to B, which is the same distance of F to A. So we're causing a partial circle to be drawn where we're drawing the arc of a circle. In a similar manner, we can consider the distance from C to E to be the same as the distance from D to E, which is the distance from A to E. So we've got one empty circle, and then we've got the other empty circle. Now, all you have to do is just find two distances for this question. You will find the distance from F to B, F to A, or F to C, and then you'll do it with the blue empty circle, which is E to C, E to D, or E to A. That is all you literally have to do for this question. So how do we do that? Well, we just need to use the distance formula. So first thing I'm going to do is I'm going to label the coordinates on the screen, and let's see how we'll do that. So this is going to be 2, 4. So the most important thing is we're labeling the vertices, and then we're going to label two of the random points. So F to B, for example, let's label B. So B is 4, 8. And then, for example, we could also label A. A is going to be 6, 2. So we're just going to work out two of the distances using 4 coordinate pairs. So let's get on with that question. Let's first of all work out the distance of A to E. So I'm going to do a square root because that's involved with the distance formula, and we're going to do x2 minus x1, so 6 minus 2 squared, plus y2 minus y1, which is 1 squared. So the distance from A to E is going to be 16 plus 1, and all square rooted, so it's going to be the square root of 17. Now let's work out the distance of F to B. So F to B is simply going to be the similar pattern. So we're going to do 4 minus 2, which is 2. It's going to be 2 squared, and then 8 minus 4, which is 4. So it's going to be 2 squared plus 4 squared. You can already see this one's going to be bigger because we've got the 2 squared rather than the 1 squared. This is going to be the square root of 20. So that is going to help us find our answer. Square root of 17, the square root of 20. The largest empty circle is going to be the one involving F, B, F, A, and FC. But how do we display this when we write our answer? Well, it's beneficial to actually get the numerical answer here, which is great. And then you can just compare them. So you just say one is larger than the other. Therefore, the largest circle is at F. So let me finish off my question here. So I would just say 20, square root of 20 is bigger than the square root of 17. And then you just write a defining sentence such as the following. Therefore, the largest circle is at F, not at B. Now, you don't need to write the latter bit. I'm just writing that for completeness in this video. That is the end of part 1 of this video. Thank you for listening.